Hi, Peter Rose, Longwood Currency Trading. This video is going to spend some time talking about designing a trading system, a trading plan, how you would build that. And because I'm a computer software engineer, and I have a lot of math and stuff behind me, I've written simulation programs and in different types of trading. And, you know, you use the logic for how you do anything. You replicate that through a series of steps, right? So when you're writing a computer program, you go through a series of steps dealing with each individual decision that you need to make. Now, if you don't have a computer programming background, you still need to understand how to go about making those choices and the branch decisions that you need to make. So, and you can learn that stuff without knowing how to do a computer program. But what I'm going to do later in this video is we're going to get onto the whiteboard and I'm going to show you how I would design a simulation program so that you can see those steps and the thought processes that you go through that in fact you would need to go through in order to develop a plan that you don't have to figure it out on the fly. You know exactly what steps you need to take in order to successfully make your trade happen. This isn't how to make a trade, it's how to trade. There's a big difference there, and I think it's a critical one that you understand when you're sitting down thinking about trading and exactly what you're going to do in order to make that happen correctly in your experience. So that's why I'm just gonna break it down as a computer programmer would look at it. In fact, I'm writing a simulation program right now. I had been talking with my friend Langers based on a video that he had done. Langers is the scruffy trader. He's over in the UK, and he stages out his positions, and I had never done that before. I go all in and then I go all out, because the idea originally was if you stagger your positions out as you go, you reduce the average win by doing that, and therefore you're not getting paid fully for the risk that you take. And that was a little short-sighted, I think, on my part, a little greedy too, because I was trying to really max out the profit. I don't know what the exact percentage difference would be in, all out, but I will tell you it's significant enough that you need to have a good win-to-loss ratio in order to make up that differential of not having that extra gain when you do stage out. In any event, based on changing the way I think, and I've done a video on that, and I'll leave a link there for that, and I've also done some blog posts about staging out as opposed to all in, all out type situations. So anyway, I thought it would be incumbent upon me, in order to do simulation analysis against a staging in and a staging out process. I never stage into a trade. I just, if it's worth doing, you know, I go all in. If I'm wrong, I just get out. If I'm right, then I wanted to see, well, what would be the ramifications of staging out of that trade? And so that's the computer program that I'm writing now. I'm probably about 1,000 lines or so into it. There's a lot of other ancillary utility code that I had to write in order to support this particular application, producing a random number generator, producing random price action candles, and then a lot of utilities to do that. I'm also probably going to write a little graphing routine to take the prices that I develop randomly and then show them on a graph, so you can look at the graph and compare that with the results of the trading that went by, and kind of get a visual of it a little bit better than just seeing how the results did come out. The idea there in the staging out process will be how many times you stage out, where you stage out, where do you set your initial stop loss, what value should that be in proportion to the staging out values that you have, What's the criteria that you use for determining the profit target levels? You know, all these things are considerations that had to be taken into the mix of the program itself, and also just looking at the thing from a trading standpoint, from somebody who would not do a computer program at it, but just looking at the process of staging your trades out. How best efficiently should you stage out? Should you stage out closely and let one run? Should you stage out long and pull them all off at the last point? I mean, what's the sweet spot there? And that's what the simulation will do. We can run hundreds and hundreds of thousands of iterations, and we'll be staging out 5 lots that form that position, so that it will be a mix between where do the different profit targets lie, you know, how far apart are they, how many lots of the 5 will you stage out at each one? Are you going to take 1 off at the first stage out point, or are you going to take 2 off? Are you going to take a third, and a third? Are you going to take half at the first point and let the rest of them run until all shit goes out? I mean, and then if you're going to let one of these final things run, what criteria do you have to close it out? And that's a whole other analysis that you do. I'm not sure I want to go to that point in this particular simulation program. I'm really only trying to evaluate staging out over set points. I could probably write an ancillary program later that would take into consideration staging the rest of that out. Anyway, that's the long and short of the thing, and I'll repeat this whole process as I go through. It's going to be a long video because I want to show you what the thought process of a computer developer, applications developer would go through. And it isn't that you're doing that in order to write a program, but you need to think in those steps, in those sequential and very logic steps. And in fact, that'd be a good idea. I'll write a flowchart for the program, and you know, we'll take a look at that. Anyway, I'm out here because it's such a beautiful day. You can see the trees in the background behind me. We're in New England, by the way, in New Hampshire, and this is just the early part of October. This is a very, very early fall that we had this year, and the reason for that is because we've had some really cold snaps, and then it warmed up, and then some more cold snaps. So it's been really, really nice that that we've got this early fall, but it has become a little too early. It's very early, in fact, because we've been under a drought. Everything is so very dry. You can see that the trees, even though this is early October and our prime leaf here, let's go way out there, even though our prime leaf area here in New Hampshire, in the Lakes region of New Hampshire, would tend to put the full foliage color in this area, and up in the White Mountains area, second week of October or something like that. That would be full leaf. We hit full leaf down here last week, and so you can see that from the colors that I had shown before, they're not the really bright, vibrant colors that we had just a few days ago. So they've started to mute themselves, and the early muting is because of the drought situation that we've had. So anyway, I wanted to come out here and just experience the color. My wife Sue and I had gone out day before yesterday and taken a local fall foliage color drive and some walks in the woods around. A couple of days before that, we had taken a much longer drive up around the Lake Winnipesaukee, north of Lake Winnipesaukee area, into Sandwich and Moultonboro, all those areas up in there. We've done quite a bit of short day trips. Some of them have been 7-8 hours, just to kind of check the foliage. We were a little late getting up to the North Conway area. That was just recently, this past week, 3 days ago, and because they had already gone through the full leaf. There was still some pretty bright colors, but it wasn't as intense as it normally is up there. And certainly as you look across the valleys and things to the mountains in the distance, you would normally pick up these brilliant colors splattered all across the hillsides and of the mountains. And those were very kind of muted, and already actually going to the lighter rust colors. Let me see. If we look up into here, you can see what I'm talking about up there. Those rust colors. That's what we found up in the North Conway area just a few days ago. And in fact, just even a little more muted than what I'm showing here. So anyway, that's my that's my travel log for the day. What the hell does this have to do with trading? Well, you know what it is? You have to appreciate yourself and your life that you have in order to be a successful trader. If you're an asshole, you're not going to be a very successful trader. And if you're caged in and you're not out experiencing life, then you're going to make mistakes in trading because you have unrealistic expectations of what the world is all about. So you need to get out. You need to have a good time. Yes, we're in the middle of a COVID pandemic, and there are certain areas that are really, really severe. We stay out of them. You can walk these mountain trails and not run into one person for hours. And so it's important to get out. Now, for those of you folks that are in the cities, look, I grew up in Chicago, so I kind of know about city living as well. And man, that's a tough road to hoe, trying to get out and without running into crowds and crowds of people. But you have to get out. You have to experience the life around you. You just have to be careful. Just when you like you're trading. When you're trading, you don't go into the trade unless the situation is safe and there's volatility there in order to provide good trading opportunities for you. You have to kind of look at the landscape. What's the board look like? The chessboard. What does it look like when you sit down to it after coming back maybe from a bathroom break? You take a new view of it. You know, what's going on there? What's happening? Where can I be safe? Where is it dangerous to move my pieces? Where is it dangerous to move me? Where is it dangerous to take a trade? And where would it be okay to take a trade? We can sort of make those decisions on our own. If you're fortunate enough to have a technical background with a little programming, or at least you understand programmatic solutions, then I think you'll find this video really, really interesting, as well as maybe adding, if you're not a programmer, at least adding to your repertoire of tools that you can use to formulate, if not on a piece of paper, then at least in your mind, how to correctly go about an organized and chronological process of looking for trades, placing trades, and then managing those trades through to fruition. So we're going to take a quick sweep through and we're going to see you back. Well, first of all, what is a computer simulation and why bother? Before I can answer that, I'm going to have to make up some coffee for myself, because you just can't program, you can't trade, you can't do much of anything without having a cup of coffee. If I was going to write a simulation for making this cup of coffee, I'd have to be really specific. I'd have to talk about all the details of going in the kitchen and getting my little basket and all this stuff here. But to cut to the chase, the simulation of how you make a cup of coffee is going to be relatively simple. I put the coffee in a basket, I close the basket down, turn the coffee maker on, and as you can hear, I'm making coffee. So if I wanted to simulate that in a computer program, I'd have to have a coffee machine, I'd have to have a cup, I'd have to have coffee grounds. Those are components, or actors. We'll talk a little bit about that later. And that comprises the stuff that's going to be in the simulation. And then I'd have to tell the computer what to do with that stuff. I'd have to say, well, the first thing you got to do is take the coffee and put it in the basket. You might have to say, open the jar and then put the coffee in the basket. You have to be really specific in computer programming. And so if you're not a programmer, go through all those details, you're going to get lost in the woods with this whole shitting thing, and you're not gonna really appreciate what's going on. So the stuff that we'll be talking about is going to be more like, I'm going to make a simulation to do coffee. I load the coffee into the basket, put the coffee mug under it, turn the coffee pot on, and I end up making my pot of coffee, my cup of coffee for the day. So it's really simple. Now you can get, as I just showed you, you can get really complex, and you can expand out and out and out with bringing in more and more and more detail. And that's the danger that computer programmers face. They put too much stuff into the program. So one of the marks that you have to hit when you're an applications developer is find out specifically what you want to do and only program to make that happen. And then if you get a little further along, you say, oh shit, man, I need a little bit more information. Like if I was programming the coffee pot simulation here, and I only had the coffee maker and the cup and the spoon, but I didn't have any coffee, and I got along and I got to the point where I had to put the coffee into the basket, I'd have to go back to the beginning, create a coffee object so that I'd have that object to put into the basket. I hope that all makes sense. Of course, the next question becomes, in our little coffee simulation thing, what we've done is we've simulated making a cup of coffee. We didn't finish that simulation because it might not be finished until you add in some cream to go with it. And then exactly what are you trying to simulate when you made that cup of coffee? Even if I took it to this point here, what's the point of the thing? Well, it probably would be tasting the coffee and saying, well, that's pretty good. But isn't that the real simulation? Why would I simulate making the coffee when the real simulation is what's the number of tablespoons of coffee I put in, how much cream do I put into it, how hot is the water? Those are the variables. That's part of the preparatory work of building the simulation, so that when I run the simulation I can simply say, okay, I've got 2 tablespoons of coffee here and it's such and such a temperature, and I put 2 hits of cream in it. Nah, I don't like that. Now I'm going to run another simulation against that, and this time I'm going to use 1.5 tablespoons of coffee, you see, and then I'm going to taste it. And so the results of that are building metrics, and then at the end of running 1,000 simulations with all different kinds of permutations on what you've just done, you create a whole bunch of these results, and then you can go back and say, gee, the best results that I had, the best flavored coffee that I had was 2.21 tablespoons of coffee with a certain temperature and 1 ounce of cream, or some stupid thing like that. You could get that data out. You could analyze that data for whatever the conditions were that produced the perfect kind of coffee for you. And so that's the why bother part of doing a simulation. It's not just to watch I I did a simulation when I got out of college. This is back in the early 70s. Well, it'd be the late 70s, I guess. I wrote a computer simulation for, I had a whole bunch of destroyer objects that were out running around in the ocean, and then I had a submarine object, and they were going out to hunt the destroyer. And so there wasn't any real simulation. It was simulating a war environment, but there's the difference between a simulation and a game. I wasn't going to be able to extract any useful data that could be used for something later from the game. I might get better at playing the game, or I might get better at programming the game, so it was more interesting, but as far as getting any useful information out of it, I wasn't. So when we're writing computer simulations against price action, we're not just we're just not printing random prices bars out on a graph and looking at it and say, well, isn't that cool? You actually have to have some useful information that comes from that. So if I'm testing a moving average crossover system or whatever, I can pick different parameters for 8 cross 13, 8 cross 25, 8 cross 42, 13 cross 20, 13 cross 42, and compare all those things against those prices to see which combination produced the best results. That's a simulation. So what's my experience with all of this stuff? Not only with the computer stuff, but also with the trading. I had a degree in physics in '72 and was doing computer programming back then in BASIC and Fortran for my physics and mathematics work. And when I got out of school, that was when the Apple II Plus computers came out. I bought one, loaded it to the max, and started programming in Pascal. I was interested in finance even back then, and so it wasn't too far after that that I began looking at the stock market and looking at options, actually. I had a broker that was very active in options, and I fell in with him, and at one point I was one of his most active options traders. Not that I was doing really, really big stuff. I was just in there all the time trading options. And so I was writing computer simulation stuff against stock price movements, and then obviously because I was doing options are written against stocks, and there's a time differential part that deals with the movement of an option in relationship to its stock price. And so some of that programming gets to be pretty tricky. There's a thing called the Black-Scholes equation that actually was responsible for the demise of the entire financial system back in when the long-term capital management collapsed and everything. They were using the Black-Scholes equation. And the guys that developed that equation worked for long-term capital management, and they had left out some of the really critical risk management. They were doing their risk analysis based on an improper risk curve that was built into that equation. But so it became relatively difficult because the equation is difficult in itself. So what I did is I developed my own model, and I wasn't doing very well in options trading. I lost a lot of money options trading, and after a while the programming that I was doing at that time revealed to me why I wasn't doing good in options, and I got out of it and went on from there. I wasn't a fan of stocks. I didn't care for options. Commodities was a big thing at that time, and I got Larry Williams' book, and I read that, and that was very interesting. There's some nice characteristics in commodities. I began to write programming against commodity prices, but the thing that always caught me was the gaps that would occur that would lock limit, and you just can't get out of that. And so if you get trapped in a simulation, then you're sure going to get trapped live in it. And I knew a few guys that did get clipped pretty bad in that, so I never got into the commodities. I discovered currency prices in 2007 and started writing programming applications against that in probably 2008 or 9, and I've been writing different kinds of simulations and applications against currency prices since then in different types of things, graphing as well as real pure simulation stuff. The current project that I'm working on, and I am working on a current programming project on currency pricing, is to study and to do a simulation on the results of that, because you have to have the results from a simulation, is given the random price action that you can have, what would be the most, two questions asked, what would be the most profitable stage out process? Do you stage out all 5 transactions at once? Do you stage out 1 and then stage out 3 and then stage out the last one? Do you stage out one, you skip a couple of profit targets and stage the rest? What combination of profit target, staging out, in relationship to how you float the stop behind that, what's going to give you the best scenario? I did a simulation like this, probably 6 or 7 years ago, but it was based on a different set of rules, and so I'm gonna rewrite this, and it was a little. It wasn't. I can't go back to that program and change it because I didn't write it to be malleable to be changed. But that's the current program that I'm working on. And why is this all going to be relevant for you? And in your trading, particularly if you're not a computer programmer. Well, I think it's all about the way that we look at problems. How do you break that problem down into sections and then formulate simple solutions to each one of those sections? And then when you put the whole thing together, it's pretty complicated, but you can't program against a complicated system. You have to break it apart into component pieces. Somebody asks you to drive a Formula One race car at the Daytona 500, and you'd never driven a race car before. You'd be a little hard pressed to just jump in the car and drive it. You know, there's certain steps that you'd have to take in order to learn the differences about the car and what it's like to go 150 miles an hour, and all that sort of thing. So you'd kind of have to take each one of those experiences and break those down and solve what's the solution to my fear of going 150 miles an hour. You solve that. You don't just jump in the car and solve the problem. How do you steer a car going 150 miles an hour? And how do I deal with my fear of a car going 150 miles an hour? So the process of computer programming analysis is breaking complex problems down into their component pieces, solving each one of those problems, and then figuring out a way to hook all those pieces together so that they make sense. And that's what I did for 33 years. And I think that though you don't have to be a computer programmer, you can benefit from the principles that we use to break complex problems down into component pieces and learn how to solve those individual things. You don't have to do that programmatically, but you need to go through that process from an empirical process of looking at the complex problem and saying, well, how do I figure this out? I'm looking at a TV, brand new, 4K TV, and it's got all these places where you plug shit into. Well, how about just where do you plug the power cord in, and where's the power button? Let's do that first. And so how we look at the world around us allows us to either be successful in that world or to be a failure. If we don't look at the world correctly, it's just the basic living world, going to work. Look at the politics that you're involved in your work environment. You have to look at the political situation that's there, find out who the big dog is, and don't piss against him. I had a friend of mine rode motorcycle. He's former Hell's Angel, but he was always, when we'd get stopped driving along by one of the cops, they'd want to measure the handlebars and all that crap. And he was very polite to the policeman. He was complimentary. He stepped back. He didn't. And when we drove off, I said, how do you control yourself against that? Because he's trying to aggravate you so that he can put the wood to you. And he goes, you never fuck with the man behind your bike. And what he meant was, don't mess with the guy, because ultimately it could get really bad and you could lose your motorcycle, either because the bike would be impounded, or it costs you so much money in fines and stuff that you can't afford to have your bike anymore, or they just keep looking for you and they stop you every time you're out with your face in the wind trying to have a nice day. So when you're in a job situation, you find this big dog and you don't aggravate him, because he's probably the guy behind your paycheck, right? And so learning how to do these evaluations against complex situations is paramount for you if you're going to be a currency trader, stock trader, or anything. It's a very complex system. And if you just sit down and think that you're going to turn this thing on and hit bid ask, you're going to flatline. And because 90% of the traders lose 90% of their money in 90 days, there's a high likelihood that that's exactly what's going to happen. Okay, let's get into the weeds in a little bit more detail here. Put my coffee down. The first thing when we're developing a simulation, we need to know what the components are. What are the components, like the coffee maker and the coffee cup and the coffee beans and that sort of stuff? In computer programming, we would call these actors. In other words, it's a main feature of the movie is the actor. And so what are the main components of a simulation or a computer program? They're called actors. So we talked a little bit about the fact that we were going to need some price information, and we are going to need to talk about transactions and how you enter the transaction and exit it, and and all that sort of stuff. So let's go a little bit into detail here. Let's start with the prices themselves. We're going to have to write an application that generates random prices, or we're going to have an application that calls out to some data source, a database of market data, that brings information back that creates this price object. And for simplicity, our price objects are simply going to be the date the transaction occurred, the high, the low, and its close. So this represents a price bar or a candle. And we get that information from some market source. Now, the whole thing of a trade is it's called a transaction. You have an enter date, an enter price, you have a close date, and a close price as a simplified manifestation of what that transaction is. So you make a trade, that's a transaction, and you close that whenever it happens. However, you can open with one transaction, then you can add a transaction to it, you can trade again and make a third. So you might have 3 transactions going in this trade. But the trade, the definition of a trade is you do something. The definition of a thing is a position. So you make transactions that create the overall position that you have. So it's the transactions that you close, and when all the transactions are closed, the position is closed. All right? It's just a way of looking at the components of the application and how you put this stuff together. So we're going to create a position object, and all it's going to have on it are a bunch of transactions. And in the simulation that I'm going to be doing, which is to look at the efficiency of staging out along with what sort of trailing stop situation will we need to do, I'm going to be making 5 transactions, and those transactions therefore will have different closing dates and different closing times, although the enter date and the enter price will be the same, because I'm going to go all in with 5 transactions, 5 trades to create my position, and then I'm going to dribble those transactions out as the thing goes. Now, other properties other than the enter date and the close date and stuff that a transaction could have and should have, might have an ID. You have to know whether did I go long or did I go short. What lot size do I have? A transaction could be 5 lots, it could be 1 lot, it could be a mini. It doesn't make any difference. What currency pair am I trading? Now it's going to be important to know. And who made that transaction, the trader. So when it goes south, we know who to blame. We know whose record to look at. So that's other information. But for the purposes of our simulation, do we need to know who the trader is? Do we need to know whether it's long or short? We don't need to know any of this stuff. All we need to know is when did it close and what price did it close at. So part of your job as a trader is to eliminate useless information that you don't need in order to solve the real problem. Too often, people get all involved in reading books and listening to this crap, and it just complicates things. Look, you hit the bid or ask, you look at it, it worked or it didn't work, and you close it. Whenever it either worked for you and you hit a profit target, or it didn't work for you and you close it to stop. It's pretty simple shit. So don't try to complicate it. And you would only complicate a simulation like this by wondering what the lot size is in the pair and who the trader, who gives a shit? Yeah. So you got a bunch of these transaction objects in the position. And then you've got this rules object. And all the rules object is going to do is it's going to take one of these price objects, and it's going to bring it, it's going to take this price object, and it's going to drop it down, that's my ink is running out here, and it's going to drop it down into here, and it's going to run rule 1. If A, do this, else if B, do that. So I could say if a stop was hit, then close all the positions, or close all the transactions in the position, which effectively closes the position. So you got a bunch of rules like this. You could have one rule, and you start out when you're doing a program or when you're looking at building a trading system for yourself, you just start out with one rule. And that rule is always the stop loss, that initial stop loss, because that's what you need to do. That's your risk-reward ratio, right? So you got to know what you're going to get out with. What's your stop when you open the position? So the first thing you're going to want to determine is what's the stop, and what do you do when that stop hits? Do you want to get out of one position or two? No. If you get hit with that first stop, you're going to want to get rid of the whole transaction chain. You're going to want to close the position and try it again, because you were wrong. Why would you get out of one transaction and wait until it gets more wrong? That doesn't make any sense. You can stage out. That makes sense, but you shouldn't stage in. A lot of people say, well, I'm going to stage in with one lot and see how it goes. If it goes against me, I just lose one lot. And then if the next time it goes in, if it goes in my favor, I'll bring in a second lot, and then I'll bring in the third one if it keeps going. Well, the thing is, how far is this going to have to go before the average of all these additional transactions brings the average so close to where the current price is that just a small drop down will take the position out anyway? If you're wrong, get out. Okay. So anyway, that's how you would build you'd build a rule. Okay. So what we just did in our phase 2 of our discussion here is to talk about the components or the actors that are involved in our simulation. Okay, so in the last phase of this discussion, we were talking about the components that we were going to need in order to put this thing together. And so now what we want to talk about is the association between those components and what all that has to do. We talked about our prices position, our rules, and all that stuff. So I'm going to go through this and show how all these things are associated together. We have a database that has all the information that we need in order to put our prices into an object, which we're going to call our prices object. So we need some object that's going to control all this stuff, so we call it a controller. So the controller is the thing in a computer program that you open up and start the program with. So you open a program, and in that program it calls out to the database, and it gets this information and brings it in, and it creates a price object, that high, low, close, that type of thing. And we don't just need one high, low, close. We need like 100 or 1,000, or how many of our prices we're going to run the simulation. It doesn't really do it much good to run the simulation more than a couple hundred bars of the frame size, or the chart frame size, time frame size that you're working on, because you can accomplish most of what you're going to be trading during that period. You're going to be making several trades, even on a daily chart. You go a couple of hundred days. That's a year's worth of trading. So you're going to need a lot of these, and there are ways to designate that this is a list or an array of them. But in any event, the controller goes out to the database, gets the information, brings that information back in, and builds a list of these price objects. Now, that's the prices that are going to run against our simulation. That we're going to run our simulation against. What we have is we're going to be making trades. Each trade creates a position. You can make 3 trades and have a position with three trades in it. So we're going to call those trades transactions. So we're going to have a position object that contains a list of transactions. So in my simulation that I worked on, I'm going all in at the beginning with 5 transactions to form my position, and then I'm going to stage out those 5 transactions over time. So I'm going to have 5 of these transactions that are going to be put on this position object. Now, you'd say, well, why not just use the transactions? Well, the position object has other information in it. We don't need to concern ourselves with it, but it contains a group of transactions. So the controller goes out and says, okay, look, based on certain information that I find in the prices, like what's the first date that the price is created on, what's the first closing price, because that'll be the opening price that I open my simulation on. So my first transaction will have an entry price of whatever this price is on that date, and that transaction will have the date of the close of the price object. So you see the interaction and the association between some of these objects. So the controller goes out, looks at the prices, gets that information, creates a bunch of transactions, and populates a position bean, and then it contains that position on it as well. And finally, that becomes all that step is pretty agnostic to whatever the simulation it is that you're going to do. You're always going to need to go out to the database or go out to a live source and bring in a bunch of information and create your price objects. And you're always going to have to create a bunch of transactions and put them into a position bean. Now, what you do with that is going to be based on our rules object. If such and such a price is hit, then that means I want to take one of my transactions and close it. That would be a rule. We'll get into that a little bit later. But the controller is responsible for associating and gathering all these different things together and creating a list of prices, a position bean with a bunch of transactions in it, and then a rules bean. And this is where your kind of brain has to really do a lot of work. I spent a lot of time. I can build all this stuff in a few hours. But this thing here could take a week or 2 weeks in order to build and to clarify and to get it right, because you have a lot of trial and error in trying to put this thing together. This is really the core of the whole thing. Well, by themselves, they don't do anything unless there's something that interacts on that. Well, what interacts on this? What creates the prices to move and for the trader to go in and make transactions and make decisions? It's a market, and we call that a business object. I'll mark it BO, market business object. And so when the controller creates the market business object, it says, I'm going to give you these prices, I'm going to give you this position, which has all these transactions, and I'm going to provide the rules for you. And so when you then program the market to do its job, which we'll show later how to do, it's going to spin through all these prices, look at the rules, and adjust the transactions accordingly to that. So this is the kind of like the brain of the whole thing. This controls it. This is the brain of the simulation, and the rules object is the simulation itself. So the order of doing all this stuff is that you create the controller first, then the controller goes out and gets the market data. It builds many price objects from that market data. It builds the position object, and then it creates a bunch of transaction objects where you're going to make the assumption that the first price object that you have is the date and the price of the entry of each transaction. And then you got to go out and build this rules object as well. Then you create the market object, and then you call the execute method. This is a signal for execute method, and that is then all these things are passed from the controller into the market business object through the execute method. The prices, the position, and the rules are then passed in through. So that's the order of the construction on all of that stuff. Okay? Yeah, about those rules that we're talking about. Let's spend a little bit more time talking about rules, okay? Basically, a rule, as I had shown in the last section, if this happens, then you do A. Else, if this happens, then you do B. And that's the end of that. And maybe that forms a rule. This type of thing is called conditional logic, and it's used an awful lot in programming. It's used a lot in life. You know, if I go outside and it's raining out, I come back inside and get an umbrella. If I turn my car on and it stutters, then I take it to the repair shop. If I get out of bed and there's something squishy on the floor, then I got to clean up the dog poop. Okay, it's conditional logic, for God's sake. And everybody does it, but some folks who are not in the process or the habit or the experience of solving problems that require constant application of conditional logic in order to come to conclusions, do this stuff sort of in the backdrop of their minds, and you solve things. It becomes much more efficient and a happier life if you consciously understand that conditional logic process that you're going through in order to achieve some result that you're trying to do. I want to cook a chicken dinner from scratch. What do I need to do? Well, if I go to the refrigerator and there's no chicken, there's not much I can do. So I got to go to the store. So the first thing I have to do is I have to make a shopping list. I mean, we do these things so naturally that it's very easy for us to forget stuff, so that we end up at the store and we go, shit, I forgot, do we need more Parmesan cheese? Or that's the problem. So if you're going to be trading, you need to have the discipline that every time you make a trading decision, it's based on some conditional logic decision that's made that makes sense. Because if it doesn't make sense, or it's in the wrong order, I don't know how successful you're going to be with your trading. The problem with folks like me who are very technically oriented and do all this kind of stuff is that we tend to make things more difficult than they really are, because we're trying to solve problems that really aren't there. Again, the real problem is, do I make the trade? Why do I make the trade? Well, because all of my experience tells me that that's when I should make the trade, not because the fast MA crossed the slow MA. That's stupid. It's your experience. But the basis of that decision comes at a long line of successful conditional logic decisions that you've made. And so you need to everything that you do, you need to break it down into this process. And believe me, this can all get very messy very fast. This is a simple two-conditional. I could have just had one. If this happens, do A, and I'm done. But that's never the case, right? You always have to have an option. Well, look at this option. This is one string of if-else statements. If 1, do A, else if 2, do B, else if 3, do C. But then continue on and check the result of C, and if it's equal to 22, then I do this. However, if the result of C is 40, then I do this. Otherwise, there's a problem that's occurred, and I end the simulation here. However, if I never go into 3, I would never get to this choice, so the simulation wouldn't end here. It would only end if it wasn't equal to 1, or it wasn't equal to 2, or it wasn't equal to 3. It would end down here. I'm teaching programming here. That's not the point of the thing. But you can see that this gets pretty shitty pretty quick. And that's, as a trader, you can't afford to do that. If you're thinking about building a trading plan, which is a series of these conditional logic steps that you need to go through, what order do you need to go through things? And if this happens, it might change the importance of doing something else first. you need to be aware of that sort of thing, okay? So that's the structure of the rules that we're talking about. So the next question here is, what sort of rules do we need? So what sort of rules then do we need? And the answer depends on what's called the problem domain. The problem domain is a simple statement of what you're trying to do. If I'm going to go to the grocery store to get milk, my problem domain isn't start the car and follow the rules of the road to get to the store. The problem domain is get to the store to get milk. How you solve that problem domain, you could walk there, you could take a car, you could take a bus. That's part of the solution. That is to determine the result is to go to the store and get some milk. And so a simple example for what I'm doing, and the problem domain that I wrote when I started writing my simulation application, was to find the best profit target stage out pattern as a function of stop loss placement. Couldn't be any simpler than that. I don't talk about building controller objects or where I'm going to get my prices from, or any of that shit. That's all background noise. What do I really want to know? I want to know the best profit target stage out pattern as a function of stop loss placement. And what you do with the problem domain then is you write rules to solve that. So I wrote some down just to give you an example. For example, rule number 1: where do I initially place my stop, and how do I then trail that stop? So there's a rule that's going to need to be made to do that. Second rule: how do I determine the best pip distance separation between profit targets? Do I spread them out 5 pips apart, 10 pips apart? What distance is going to be optimal? And a third example of a rule would be which permutation of staging out lots provides the best trading result metrics? So once I collect all the data of all the permutations that I'm running through, then I have to answer the question here. The main problem question is, how do I spin through those results? So how do I prepare a results object that will enable me to extract the answer to the question of which permutation of staging out lots provides the best trading result metrics? And so that's how I wrote my program. I start off with this, and I figure out, well, what are the actors that I'm going to need in order to get me to these answers? What data am I going to need? I build those objects out, and then I say, okay, now I need a rules object. What do I need to do? How do I get these prices to come in and interact with my rules object? That's a programmatic issue. It has nothing to do with the problem domain. And then once I get that interaction going, I can write my first rule, whatever that first rule is. So that's the essence of what sort of rules do you need then? Well, those rules are dependent upon what we call this problem domain, okay? All right, so we've got some rules that we've written down, but that doesn't necessarily indicate that we know what order to put them in or how they fit into the overall flow of the application, and that's where a flow chart comes in, and so that's generally the next step. Now, if we're doing object-oriented programming, there's like 4 different kinds of these charts. There's action diagrams that show which object calls which object and what returns and when that happens and all that crap. But there's just this basic flow chart, which is a progression of thought through the solution of the problem. Coffee is important. Okay, so in our application, and this is, again, this is just really simple. This describes the solution of the application. This is how the problem domain is satisfied. It isn't what you do, it's how you go through the simulation. So you start the simulation, and that brings up one of those prices. So you take one of those prices, and you look at it with one of the rules, and you say, was one of my rules hit? Now, those 3 rules that I provided there, this turns into a pretty messy diagram if you put all this detail in there. Because this rule could be, was a stop hit? Well, if a stop hits, then I'm going to do this. But if a stop isn't hit, then it goes to a what is a profit target hit. You want to take care of the stop first, but if the stop isn't hit, then you look for the profit target. And so there's all kinds of profit target rules that you have in there. Regardless of that, it doesn't make any difference. The simulation says take the next price and run the rules against it. Was a rule hit? Well, if no rule is hit, fine, boom, you go back up and you hit the next price target. And you say, is a rule hit? Nope. Okay, back up, get the next price bar. Has a rule hit? Nope, back up, get the next price bar. Rule hit? Yes. Okay, then you process that transaction. Well, what does that mean? Well, again, there's rules for how you would process it, but there's processing the transaction is the issue that is going to be solved at that particular step. Now, after processing that transaction, is everything okay? If it's not okay, you're going to end the simulation. What could be not okay after you process the transaction? Well, if all of the transactions had been processed, you're done with the simulation, so something is wrong. You're done. So, boom, you go to the end. However, if there are open transactions, for example, let's say a profit target rule was hit. I process the transaction and the rule is take one transaction off and do profit, and then what you want to do is everything okay? Yes, it's okay. I'm going to go back up and I'm going to go to the next price bar or the next profit target or whatever it is, because I need to see if that next profit target is hit in that same price bar. Something like that. You get what I mean? So there's these conditional branches that you go through, and this is just a diagrammatical representation of conditional logic. These circles, these flat circles, ellipses are generally start and stop things. Square boxes tend to be things that you do, and triangles are decisions that you make. So you know enough now to write a conditional logic flowchart diagram. Isn't that swell? Okay, well look, the sunlight is beginning to stream in through the windows in here in my library, and it's starting to bleed over onto the whiteboard, and we need to close this thing down. So if you look at the bare bones flowchart that I wrote, the actual flowchart that I have built my application from, or I'm still in the process of doing that, is over on the left side of the screen there. You see, I have the same start thing. I go to the next candle. The first thing I check is a stop hit. If it is, then it goes over here to the left. Then if a stop is hit, I close all the transactions. I come down here. I log the transaction. Are all transactions closed? Well, they are, so I want to end the simulation. If I go back and I do, is a stop hit? No. Then is a profit target hit? If no profit target is hit, then I go back up and I go to the next candle. If a profit target is hit, then I log the transaction. Are all the transactions closed? No, because I just did one. Was it the last profit target that was hit? If it is, the simulation's over. Is it the last candle? If it is, the simulation is over. Well, then I need to check to see if the next profit target has been hit, but it's the same candle. So I go up here and come back and check to see if the next profit target was hit. So that's the more complicated and complete flowchart of the application, as opposed to just what the flowchart of the simulation was. Okay. Okay, so wasn't that fun? Look, I'm out of coffee, and I need to take care of that before I do anything else. I hope you enjoyed the discussion of the simulation, and it just wasn't for entertainment purposes. I really feel that it would, if you're not programmatically trained or have any experience in this stuff, I really think it's important for you to look at the process, not what to do, but why we're doing certain things, the principles of how you abstract key nodes or points within a complex system, figure out how to solve that problem, and then figure out how to hook the solution to that up to all the other solutions that you made. And that's how you build a trading plan. That's the efficient way of building a trading plan. Not that I'm going to get up at 6 o'clock in the morning and trade the London Open or whatever it is that you think you're going to do. That's not a trading plan. You need to be more concise. You need to be more precise. Getting back to that problem domain. Anytime you go to make a trade, what's the problem domain? When you sit down and agree, what's the problem domain? What are you trying to accomplish? And is what you're doing moving you forward to accomplish those goals? Peter Rose, Longwood Currency Trading. Have a great day. Have a great trading day.